हेलो स्टूडेंट्स, हमारा नेक्स्ट टॉपिक मोशन ऑफ अ चार्ज पार्टिकल इन अ यूनिफॉर्म इलेक्ट्रिक फील्ड। ये भी हमारे मैग्नेटिक इफेक्ट ऑफ इलेक्ट्रिक करंट का ही एक पार्ट है। वी वांट टू डिस्कस द मोशन ऑफ दैट चार्ज पार्टिकल। सपोज दैट इज अ चार्ज पार्टिकल चार्ज ऑन दैट q. Initially it is moving with the velocity small v. We have placed the charge particle in electric field. You can see that this is the charge plate, positively charged, and this is the negatively charged, so it will produce a field there, and the direction of field will be plus to minus, positive to negative. And in that case of electric field, the charge particle start moving in the x direction, but due to the electric force it will bend and its motion like that. And after the field, when the field is, then charge particle leave the field, then that charge particle moves straightly there. That is a straight line motion. This is the x direction and this is the y direction. So we have to study the motion of that charge particle in that electric field, and we will also find out the path of that. And you can see in the diagram it's a parabolic like path. So we will prove that it's a parabolic path, and that charge particle moves in a parabolic path in a uniform electric field. So this is the electric field. We placing the charge particle there. So you can write that, consider a charge particle q plus q, positively charged particle. Consider a charge particle plus q moving in a uniform electric field, moving in a uniform electric field. Initial velocity is small v, initial velocity is small v. So when a charge particle is in electric field, then there will be electric force. So you can write that electric force on charge particle, electric force on charge particle. If electric field is E, so you can write that F will be equals to QE, F equals to QE. And due to this force it will be shifted like that. So you can also write that F will be equals to what? MA. So it is QE. So A will be equals to QE by m, and you can write that A will be equals to QE by m. So the charge particle will accelerate in the electric field with this acceleration. So we can mention here charge particle accelerate with above acceleration, in electric field, So this is the acceleration. And now we can discuss the motion of direction of charge particle. It is along x direction as well as in the y direction. तो x direction की बात करें, x direction में अगर हम बात करेंगे तो electric field is along y direction. It means this acceleration will not applicable along x direction. So along x direction acceleration is 0 because this force is not applicable in the x direction. That force or acceleration is applicable along the y direction. But initial velocity is along x direction. Initial velocity along y direction is 0 because the charge particle start motion along x direction. So we can discuss the motion along x direction and y direction. So you can put it equation first point, and in the second point along x direction, if you discuss the motion of the charge particle along x direction, then you can use the equation second, that s equals to ut plus half at square. So after time t, along x direction and along y direction, we will discuss the motion of particle after time t. यानी t time के बाद हम बात करें, और t time के बाद हम कहेंगे कि that will leave the electric field. So before starting the second point, or you can write in the second point, after time t, after time t, charge leave the electric field, charge leave the electric field, charge leave the electric field and cover x distance along x direction, cover small x distance along capital X direction. So you can use the second equation, s equals to ut plus half at square. So s is x equals to, और यहाँ पर ही साइड में ही मेंशन कर दें कि here u is small v, time is t, no problem, and acceleration is 0 in this case. So in place of s, x equals to u की जगह v into t plus half, a is 0 and this is t square. So you can write that x equals to vt here. This is the term 0 here. So you can write that time will be x by v from this. This is the equation number second. Okay. And similarly we can find out for the y direction. तो y direction के लिए कैसा find out करें? Y direction हम कह देंगे कि after time t it will leave the electric field and distance covered along the y direction is small y. So we can mention that. Write down that. Third, along y direction, and you can mention the language after time small t, charge particle leave the electric field and the distance covered is small y. Distance covered is small y. Distance covered is small y. So again we have to use the s equals to what? ut plus half at square. In this situation y डायरेक्शन की बात करें, ये x डायरेक्शन के लिए बात कर लिया, तो यहाँ हम यूज कर सकते हैं कि uy is 0 but ay is qe by m, because that acceleration is applicable along the electric field. Force is applicable along the electric field, so acceleration will also be applicable along the y direction. So you can write that in place of s, it is y equals to uy t plus half ay into t square. So you can write that y equals to uy is 0 into t plus half ay is qe by small m into t square. So y is half qe by small m into t square, and you can put the value of t from equation second. It is equation number third. So from second and third, you can write that y is half qe as it is, qe by m as it is. In place of t is x by v, so it is x square upon v square. So this is the displacement of body, y equals to half qe by m into x square divided by v square. और इस इक्वेशन को देख करके आप क्या मेंशन कर सकते हैं कि हाफ qe बाई m वैसा का वैसा, और ये x स्क्वायर बाई v स्क्वायर हमने वैसा ही लिखा है. यहाँ y और x में अगर रिलेशन देखेंगे तो इट इज x स्क्वायर, मीन्स इट इज पैराबोलिक. So you can mention after that the path of charge particle is parabolic. Path of charge particle in a uniform electric field is parabolic. Path of charge particle in electric field, uniform electric field is parabolic. So you can mention that. डायग्राम अच्छे से बना करके पूरा आप इसको एक्सप्लेन कर दें अगर आपसे डिस्कस किया जाता है. नेक्स्ट क्लास में हम लोग डिस्कस करेंगे कि मोशन ऑफ दैट चार्ज पार्टिकल इन ए यूनिफॉर्म मैग्नेटिक फील्ड. अभी इलेक्ट्रिक फील्ड की बात करी, सेम वी विल डिस्कस इन द मैग्नेटिक फील्ड. ओके, सो थैंक यू.